In this video, we are going to be learning how to calculate the area of a triangle using coordinate points. Okay, find the area of a triangle which has vertices with coordinates P, Q, and R. So, to do this, the area of a triangle, when you have the coordinate points of the vertices, is, so that is area of triangle is equal to, you're going to have, so the 3 points, for those 3 points you're going to have x1 into y2 minus y1. Now, to write out this equation, just follow carefully to see how I remember writing this equation. So x1 with the brackets, that is x1 into y2 minus y3. We now write a plus, then we now get into x2. For x2 now, see how I remember it. When we start from 2, we now get into y3 minus y1. And then another plus, we now start from x3. So since we started with 3, we now get into y1 minus y2. So if you look at it, 1, 2, 3, then we start with 2. That means 3 and then get back to 1. We start with 3, we get to 1 and then 2. So this is the formula for the area of a triangle when you have the coordinate points of the vertices. Now let's write out the coordinate points of what we've been given. We have that P is 1, 2 and Q is 4, 1 and then R is 3, 3. So this is our x1, y1, x2, y2, x3, y3. Now let's substitute. We have that the area of that given triangle is equal to, we start with x1. x1 is 1. No, that is half of all these value, half of the absolute value of all these. I omitted that. So we have that half of this absolute value of, so we have that x1 is 1, right? y2 is 1. We bring down the minus, y3 is 3. And then we now have our plus, right? We now start with x2. x2 is 4. And then y3 is 3 minus y1, which is 2. We bring down the plus. We start with x3, which is 3. y1 is 2. And then minus y2, which is 1. Equal to half of the absolute value. We have 1 outside the brackets. 1 minus 3 is negative 2. And then plus 4 into 3 minus 2 is 1. Plus 3 into 2 minus 1 is 1. Now we have half of the absolute value. 1 times minus 2 is negative 2. Plus 4 times 1 is 4. Plus 3 times 1 is 3. Now, minus 2 plus 4 is 2. 2 plus 3 is 5. So we have that the half of 5, which is 5 over 2. So we can leave it as 5 over 2. Remember, this is area, so its value is in square units. Square units. Or we can get it as 2.5 square units. Never you forget to write the units, not just units, square units, because it's area. Now let's look at this question with a little bit of a twist. The equation of the side PQ, PR, and QR of a triangle are respectively. Find the coordinates of points P, Q, and R, and then the area of triangle PQR. So for this one, we have to find the coordinates of the vertices of this triangle that has these equations as the equations of the lines. And then using those coordinate points, we'll now calculate for the area of the triangle as we've learned. Okay, so let's have a sketch of a triangle. Let's say this is the triangle, right? And then this is P, Q, and R. This is just a sketch. So we're going to find these coordinates, and these coordinates. But before we proceed, let us write down these equations of the sides. So we have that the side PQ is equal to, since it's respectively, so this belongs to this, right? So PQ is 2x plus 7y plus 3 equal to 0. And then we have that PR is equal to 3x minus 8y plus 23 equal to 0. And we have that QR is equal to 5x minus y minus 11 equal to 0. Okay. So, to find this point P, that means point P is the point where this line and this line intersect. That means when we solve the equation of PR and PQ simultaneously, remember that when we do simultaneous equation, the value of the coordinate points gotten represents where those two lines meet. So that is, point P is where the line PR and PQ meets. So when we solve these two equations simultaneously, the coordinate points we are getting from the equation represents the coordinate point of P. So we now say, to get point P, let's open up the bracket for it so that later we can fill it in. We have to solve for PR and PQ. That is, simultaneously, we solve PQ and PR simultaneously. Now let us write out the equations. We have that PQ is equal to 2x plus 7y plus 3 equal to 0. And then PR is equal to 3x minus 8y plus 23 equal to 0. So this is equation 1 and this is equation 2 that we have to solve simultaneously now. So this is a kind of revision for solving simultaneous equations. We are going to be using the elimination method. And to do that, let us look at the variables, the coefficients of the variables. Now, these are smaller in value compared to this, right? So let's just eliminate x. To do that, we have to make sure that these two coefficients are equal. And then when we multiply this equation 1 by 3, this becomes 6x. When we multiply equation 2 by 2, right, this becomes 6x. So equating these two so that we can subtract them out. Okay, so when we say equation 1 multiplied by 3 and equation 2 multiplied by 2, we are going to have that equation 1, we are multiplying everything by 3. So that is 6x plus 21y plus 9 equal to 0. For this, we multiply by 2. We have 6x minus 16y plus 46, yeah, equal to 0. So when we subtract these two equations, we can have that 6x minus 6x is 0. So we've eliminated it. That's how the name came about. 21 minus 16. So this minus becomes plus. So 21 plus 16, that gives us 37y. And then 9 minus 46 is giving us negative 37 equal to 0. Now to solve for y, we can actually see that we send this 37 across. We have that 37y is equal to 37. That means we divide both sides by 37. We have that y is equal to 1. Now let's solve for x. Let us pick out any of the equation and then substitute y into it, and then we solve for x. We have, let me pick out equation 1. We have that 2x is plus 7 That's 7. Instead of y, we have 1 into the brackets plus 3 equal to 0. We have that 2x plus 7 plus 3 is equal to 0. 7 plus 3, that is 10. 2x plus 10 is equal to 0. Now, let's send the 10 across to the other side. 2x is equal to negative 10. We divide both sides by 2. We have that x is equal to negative 5. So the coordinate points for P is negative 5, 1. Now let's get the coordinate points for Q. You can as well pause the video right now and then practice by yourself to see that we arrive at the same values. So to get the coordinate points for Q, what we have to solve for simultaneously is PQ and QR. Did you see that? As their meeting point is Q. So PQ and QR. Let us write down those equations. We have that PQ is equal to 2x plus 7y plus 3 equal to 0. And then QR is equal to 5x minus y minus 11 equal to 0. So this forms our equation 1. And we have equation 2. Remember, we are solving for Q. Forgot to write that out before. Okay. So let us look at what we need to eliminate. We can multiply this by 5 and multiply this by 2, or we can just multiply equation 2 by 7 so as to equate the coefficients of y. Okay, let's multiply equation 2 by 7 so that we can have 2x plus 7y plus 3, that is equation 1. So this is equation 1. Then equation 2 we multiplied by 7. Right? So that we can have 7 times 5 is 35x minus 7y minus 77, and that's equal to 0 equal to 0. So since they have different signs, when we add them up, we now say plus 7 plus minus 7. So that plus minus is still minus, so that 7 minus 7 is 0. So we've eliminated it that way. That is how we come about whether to add the two equations or to subtract them. If the signs are different, you use addition. If the signs are the same, whether minus minus or plus plus, you use minus. Okay, so let us add up the two equations. We have 2x plus 35x is giving us 37x. 37x, then this comes to 0. 3 plus minus 77, that is 3 minus 77 is negative 74 equal to 0. Now let's send this across to this. We have that 37x is equal to 74. We divide both sides by 37 so that we can have that x is equal to 2. So let's have it here. X is equal to 2. That's 7. So let us substitute into one of the equations. I pick equation 1. We have that 2 into, instead of x, we have 2 plus 7y plus 3 equal to 0. We have that 4 plus 3 plus 7y equal to 0. 4 plus 3, that is 7. So that we have that 7y is equal to negative 7, right? We divide both sides by 7. We have that y is equal to negative 1. So x is 2 and y is negative 1. So we have 2, minus 1 as the... So that is 2, negative 1. Now let's solve for r. Now in solving for r, I've copied out the things in the next page. So to solve for r, we have to solve simultaneously these equations PR and QR, right? So we've written them out. This is equation 1. This is equation 2. So let's look at it. Let's also multiply this equation 2 by 8 so as to equate the y coefficients. We have that So equation 1 remains 3x minus 8y plus 23 equal to 0. And then equation 2 to be multiplied by 8 now becomes 8 times 5 is 40x. 40x minus 8y minus 88 is equal to 0. Now let's look at it. They have same sign, so we are going to do minus. So that's minus 8 minus minus 8. That is minus 8 plus 8 is 0. It eliminates. So 3 minus 40x is minus 37x. 23 minus minus, right? So 23 plus 88, that is a plus 111 equal to 0. Now let's send this across to the other side. We have minus 37x is equal to minus 111. Then we divide both sides by negative 37. We are going to have that x is equal to 3. Now let's solve for y. We can use maybe equation 2. We have that 5x. So instead of x, we are going to have 3 minus y minus 11 equal to 0. 5 times 3, that is 15. 15 minus 11 minus y. So I brought it across, right? That is, brought it close, not across. Equal to 0. We have that 15 minus 11, that is 4 minus y equal to 0. We have that if we send y across so as not to deal with the negative, we have that 4 is equal to y. That means y is equal to 4. So meaning that the for r, the coordinate point of r, we first of all taking the x and then the y is 3, 4. So let's get to our triangle and then have the 3, 4. I know we've come a long way, but we went all this way so as to also show us, in case you have equations of the sides, how do you get the coordinate points? Now back to the major topic of the video, which is finding the area of a triangle using the coordinate points. Now for that area of the triangle, we have that that is half of the absolute value of x1. Then we now say y2 minus y3 plus, we now start with x2. In the brackets, we are going to have y3 minus y1. y3 minus y1. And then we now start with x3. In the brackets, we are going to have, so since what did I do? So we have x2. We are going to have now x3 minus x1. That is, when we start with 2, we are going to now go to 3 and then 1, right? Then now we've started with 3, we are going to go to 1. So y1 minus y2. That is how I remember it. So find your own way of remembering this. We have half of the absolute value, then we now substitute. So, but before substitution, we didn't write them out. We should have, so PQR, oh god, so PQR, we have that point P is minus 5, 1, and then we have that point Q is 2, minus 1. I'm sorry about all this, we should have written them out. So P, x1, y1, let's go alphabetical order. So Q is x2, y2. We have that R is x3, y3. Okay, let's substitute immediately. We have that x1 is minus 5, negative 5. y2 is negative 1 minus y3 is 4. Plus x2. x2, that takes the form of 2. y3 is 4 minus y1, which is 1, and then plus x3 is 3, y1 is 1 minus y2, which is minus 1. So this becomes a plus 1. Okay, so let us open up the brackets. Equal to half of the absolute value minus 5. Minus 1 minus 4 is minus 5 again. plus 2 into 4 minus 1, that is 3, plus 3 into 1 plus 1, that is 2. Okay, we have it as equal to half of minus 5 times minus 5, that gives us a positive 25. 2 times 3 is 6, 3 times 2 is 6, 25 plus 6 plus 6, that is 25 plus 12 is giving us 37. So we have that the area of the triangle is half of 37, which is equal to 18.5 square units. So we've come a long way. I hope by now you've learned how to calculate the area of a triangle when you have the coordinate points of the vertices, and in case you have the equations of the line, I believe by now you can go through all the simultaneous equations to be able to find out the vertices of all the sides. That's the vertices of all the points, yes, and then be able to calculate the area of the triangle using the known formula. And I also want you to learn how to actually memorize this formula. We have 1 2 3 2 3 1 3 1 2, and it's, you saw the way I was always remembering it. So you can as well use that method or find a more suitable method for you.